Hello, everyone. My name is Reuven Weintraub. I'm the founder and CTO of Gidel, and I have about 40 years of experience on accelerating platforms. And I want to share with you some of my knowledge. Who of you have heard about algo trading? Okay, so algo trading is in the stock exchange where computers are competing to buy and sell. Back in 2007, I met people, and for them, 1 millisecond worth $100 million. Because there's no second chance. You have a computer, if you bid first, you get the deal, and 1 microsecond later, no deal. Okay? Then, about 10 years ago, and of that time, everybody works only with the C, and there's regulation, and people told me no way FPGA would be in the market for that. 10 years later, the pricing was dropped only to 4 million, but 4 million for 1 microsecond. At that time, if you're not in the FPGA, you're out of business. And I was so surprised to see IT manager of one of the biggest banks in the world, and he was so experienced about what FPGA is doing, and more important, how we can get a lot of FPGA designers at a lower salary rate. That's already what he told me. So going back to our need, boosting the performance. So the first question is, what is performance? So for some people, performance is the throughput, which is actually combined from 3 elements. And what we see today is that these 3 elements are getting bigger and bigger in each one of them. We have higher camera resolutions, we have higher frame rates, and we're using more and more cameras, so the throughput is coming really essential to accelerate. For others, the latency, like in the algo trading. Others may be accuracy and detectability. To be more accurate or to be more detecting can be relevant. Maybe you need to be on a drone and then the weight is more crucial, or you need to be within a small environment and then the size would be crucial. And of course, thanks Oliver, concept to market may be crucial to others, and maybe several of those. So the first thing I would say is to analyze what is your need to accelerate performance. And then, for example, with the latency, some people are saying, let's say a doctor needs to do a surgery, and you used to work with 20 frames per second, and you know you need to have 2 frames or 1 frame latency. Now you're working with a 60 frames per second, and some people are saying, okay, let's have 2 frame latency. But the actual performance you need is still the same time because the reaction of the doctor is the same time. On the other hand, as we saw in the algo trading, the latency dropped down severely. Okay, so understanding what you need. Another thing is alternatives. For example, accuracy. We all talk about AI. A couple years ago, not so far away, everyone worked at floating point for AI. Then Google came and said, you know something? We can work at 8-bit and lose only 1% of accuracy. But the fact we are working with 8-bit enables us to have a lower cost impression and to have much more logic. And maybe with that, we're going to get, with additional layers, we're going to get much better system. So these are elements to understand about the different options and capabilities that we have. And I think a very important thing is to understand that we all care about accuracy, but sometimes we exaggerate with accuracy in one point, and we lose other elements, including accuracy, on another point. And therefore, I think taking back what you need and think, why do I need it? Why do I need this performance? Why do I need that performance? And then we can realize where there's another way, there's another alternative, maybe to solve it better. And here's just some of the bottlenecks that can appear in all kind of systems. And if I'm focused just on the processing for now, then you can select the AI engine, GPU, CPU, FPGA, and so on. So first of all, I'd like to say thank you for Oliver, because I do believe strongly that the modularity is crucial with today's market. And also sometimes we want to accelerate our performance, but we are not sure what exactly the customer will ask. And also with the large quantities, what Oliver pointed out is you start with the small things, you feel the market, and then when you want to make the quantities in production, you know exactly what to do. So in that case, you can combine the two things, the low cost as a production, but the fast time to market, the fast reaction, and so on. So as I told, I strongly believe in the hybrid computing. There's things that are better to do in the AI engines. GPU, obviously, everyone knows about them, and there's things to do in the CPU. And as Oliver said, definitely the FPGA processing is something that can accelerate a lot, reduce power, and today it's not so expensive. You talked about the pricing and so on. I remember about 14 years ago, I went to a customer, and they purchased from us FPGA board that cost $10,000. And he told me, you see, the computer is $40,000. Your board is only $10,000, and it's doing 80% of the job. Okay, so when we're talking about pricing, it depends on the systems and so on. Obviously, today, the FPGAs are much cheaper, and Oliver knows it very well. So here's an example where I believe strongly, and that is if you take the number crunching and use that in the FPGA, such as the histogram, so running the data and making a table, this is a pure number crunching job, and that the FPGA can do very fast, and you don't care about latency and things like that, and also very accurate and low power and so on. But analyzing the table, this sometimes is very simple. You want to know minimum, maximum, fine. But if you want to look at specific angles in order to know exactly how to map your gamma corrections, to tailor it exactly to the scenario or to the image and things like that, this is a task for a CPU that can do a very good random thing. So going back to Oliver's concept of modularity, from my perspective, to have the FPGA IP with a CPU software that complete it as a full class, this is a module. So with the Gidel technology, we can use this kind of modules and combines all these modules in the applications. Moving into an example, okay? What you can see here is HDR example. In the HDR, many cameras are doing HDR in two ways. One way is two exposures, a high exposure and low exposure. This is excellent because they can get a good image in both cases. However, there's an issue. What is the issue that they have? Frame rate. And today, the market demands a lot of frame rate. So if you can get one frame and get HDR out of it, it would be good. However, if you look at the image, on the left-hand side, the original image, some of the data is very dark. It's in the shade. Some of the data have a direct sunlight. It's very bright. So if you're going to use more exposure time, you're going to burn the area under the sun. If you close the shutter, you have very dark areas where you have the shade. So in the processing of the HDR, you can't use just the regular gamma, because if you're using just the regular gamma, especially in Bayer images, which has a higher throughput, each pixel needs to be accelerated, but not according to its value, because then if you do it according to its value, you destroy the contrast. You want that acceleration to be according to the scenario and the area around you. And what you see here on the right-hand side is that an HDR that is taking in account the area, taking in account the coloring to make sure that we keep the coloring, and also to look at doing some edge enhancement or having an option for edge enhancements as well. If you have sharp eyes, you may be able to see some elements of edge enhancement as well, to have, again, better recognition or better detection. And here's the advantage of doing that through the FPGA. On the left-hand side, we see a large computer needs to do the processing, and it's very limited with performance. So you can see on where the arrow shows you a difference in the edging and analyzing the edges and coloring when it gets in and out the shade. On the FPGA, we can run the HDR, the gamma, the white balance, and compression all in the same flow and make it simpler. And the reason is because in the FPGA, you can run as much as logic as you want, so we can add more complex algorithms to develop the algorithm compared to the software, and that's why it's better thing. And definitely we can run that on speeds faster than gigapixels per second, which is today demanding. Now, when we want to go from the concept to market, as Oliver said, it's very important to understand. Using modules absolutely helps, I agree. Then you have the design time, you have the coding, you have the compiling, you have the testing, you have validating, and in many cases, you do need to have improvements. You need to have a cycle and cycle and cycle. So what we found out is something amazing. We found out that when you're developing something complex, such as quality HDR or quality compression or other high-level algorithms of detection, you put time on the coding, you put time on compiling, but the most time that you put is in testing and validating, and even more than that, on the improvements that you want to do, because the improvements are small changes that you need to run through many, many videos or many, many images. And if you run those in software, the time of the validation and improving is slower. So we are offering an example of having a camera simulator that runs videos as you want into the images under the development, and then you can access directly from the host to your application and send it to a frame grabber to see the results on the screen. And finally, you can have all the features of acceleration and so on with a very small computers that we can demo on our booth D20 over here. So first of all, everyone is welcome. And the other thing is, if you have any questions, I would be more than welcome to answer you.